Welcome back to Algebra 2 Online. I just wanted to do a few review problems that will kind of get you ready for our Unit 2 test. So this first one is just using transformations to graph a piecewise function. So this right here is f of x, and we've got three transformations. Minus is going to be vertical flip, like minus of the function is vertical flip. Minus 1 inside here is going to be a shift to the right, and that'll be a shift up 2. So I think I'll do it we'll just do it in three parts, I guess. So we'll start with maybe minus f of x in green, then we'll do minus f of x minus 1, and then last but not least we'll do the full thing, minus f of x minus 1 plus 2. So if we do a vertical flip, right, we're just basically flipping, the idea is like all these outputs here of negative 2 get negated, and they're going to be up there at 2. These outputs, ranging from 4 to 7, get negated and flip, and will range from negative 4 to negative 7. So that one would look like this. So let's see, 1, 2, 3. Something like that. It's not perfect because I can't draw straight, but that would be the negative of f of x. Then if we shift it 1 to the right, I would just take this point now to be here. And we get that. That. And that. And then we want to shift everything there in red up 2. So this one's going to end, like our final answer for that piece would be up there. Whoops, that's up 1. Let's do that again. So up 2 would be right there. And then this one up 2 would be here. This one up 2 would be here. So we get that piece. That up 2 would be there. And then this just has a slope of 1. So we could really just do that. And that purple one would then be the negative of f of x minus 1 plus 2. So this question just sort of mixes together a bunch of kind of different concepts. So we've got inequalities going on, we've got function notation going on, and we've got transformations going on because I give you a parent function and I just tell you to graph this inequality based on these transformations. So we've got, in this case, like basically all the transformations you could have. We got all 4 that you could possibly have. A negative in front, vertical flip again. 2 in front is vertical stretch. We've got a plus 2, which is shift to the left. And then minus 3 on the outside, which will be down 3. And these transformations are really important. They're probably one of the most important. I would put them honestly in the top 3 things you should know from Algebra 2 going into pre-calc and things like that. So maybe off to the side, I will kind of remind everybody, absolute value looks like that v, right? And maybe I'll do negative 2 f of x first in well, that's confusing because I already wrote it in purple. So we'll do negative 2 f of x in yellow. Then maybe we will, I think we can just jump to the final answer from that point. So I'm going to, because it's a greater than, I'm going to do these two things in like dotted lines, right? And then I will do the shading last. So negative 2 f of x, if we're shifting this around, the negative, it means we're going to have a v that, well, it's not a v anymore. It's like a caret symbol. And then the slope of this was -1, and this was 1. So now it'll become -2 and 2. Or 2 and -2. So what that would look like, there's no shifts or anything, so we're still going to have that point there. And then we'll have these two slopes. And that would be -2f of x. Then if I just move it around, I'm going to take all those points, move them to the left 2. So we got here, well, I wanted to do all this together. So we're going to take like a point here, we're going to move it to the left 2, and then we're going to go down 1, 2, 3. So we get that point. Like this one, we'll go left 2, then down 1, 2, 3, and so on. This point goes 1, 2, 1, 2, 3. So right there. And this is going to get kind of cluttered, so I think I'm actually going to erase this now. So we've got this being my kind of template, I guess. Then I want to shade greater than it. So greater than it, at any point on here, I need to go greater than it. The y values are bigger than it. That's what it says. Y is bigger than this. So I get all this stuff up here, all that kind of stuff. Arrows, perfect, pretty picture. So this is another really important thing from this unit, just writing piecewise functions from a picture. So you could honestly do this two ways. You could either think of it as a line, absolute value, line, or you could think line, 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 line. So we could do it in two ways. I think I'm just gonna do it the absolute value way, because it's less writing. So let's call it f of x. And I always like to do the domain part first, so I can see that I have my first piece kind of ending at 1, and then the absolute value part will span from 1 to 6, and then the last piece is bigger than 6. Make sure that these don't overlap too. So, if this is less than or equal to, then this picks up right next to it and is a less than. If this is less than or equal to, now this picks up as a greater than, basically. So then the pieces would just be, the first one cuts through 1. It's just a horizontal line, so 1. The last one's also pretty easy because it's just 0. The middle part is the absolute value, and you do need to check the slopes to see if there's any stretching or compressing, and there isn't. If you take this point at 2, 2, you can see that you go up 1 over 1, so that has a slope of 1, and this also has a slope of -1. So there's no stretching or compressing. So all you're really doing is shifting over to the right and up. And so it's kind of like a vertex sort of form of an absolute value. You've got a absolute value that's been shifted to the right. So it's that weird backwards thing where it's absolute value of x plus 3. And then you shift up 3. And that really is the true plus 3 that you would want it to be. And that would do it. That would fully... this piecewise function would plot this if you graphed it. So these are just some random kind of concept questions that are definitely going to be important for the unit test. So if I was going to draw a graph, which is a function but not one-to-one, the first thing that comes to my mind is just a horizontal line. They are definitely functions, and these things are infinite to 1. You can have all these different inputs right here that just go to one output. Next question, is every one-to-one relation a function? And the answer is yes, they are. Doesn't matter what you think of, if you take a diagonal line, that's one-to-one. If you take a point, that's one-to-one. all of these things are going to be functions, because the only way you can get to something that's not a function is if it's like 1 to 2 or 1 to 3 or 1 to infinite. All of these are the things that are not functions. Those are like the bad ones. But if we have 1 to 1, these are really nice, simple kind of things like these two. This last question is kind of tricky, but a good concept question. So you've got f of x is negative 3. So let me actually draw it. So let's say that's negative 3. And you've got this question about what would this be. And if you think about it, just in terms of transformations, you can see it's really not that bad. You've got a minus 3 inside, which would shift to the right. But if you shift this to the right, nothing's going to happen, right? Because it's just an infinite horizontal line. So really, then you would have 2f of negative x plus 1. Negative x inside is you take any x value here, you negate it, flips over here. If you take this negative, if you take a different x value, you flip it. Double negative makes it positive, so you get like that horizontal flip. And since this is horizontal, if you flip it over like the y-axis, nothing would happen there. So then you get back to basically just 2f of x plus 1. But then these things actually would do something. So 2 acts as a vertical stretch, but honestly, my brain was just sort of pausing, because I think the easiest way to just explain this now, f of x is negative 3. So I would just substitute. I would just take, f of x is negative 3, and just literally plug and chug. So you get negative 6 plus 1, which is negative 5. And that is what this thing would be if you had that horizontal line of negative 3. So last but not least, I just want to do kind of throw-all question. This kind of just hits all the different things that we've been doing in this unit. So I'm going to start by graphing this piecewise function. And to do that, again, I always look here to graph the different pieces first. So my brain's looking at less than 0. I'm going to graph that line. So I'm going to take 0, plug it in. I get 1. Right? So maybe I'll do this piece in green. I don't know, this piece in yellow, and this piece in red. So what did I just say? 0 plus 1 is 1. So right there, open circle, because it's a less than. And the slope is just 1, so we just do that. That has slope 1. Then in yellow, I'm going to basically just take these two numbers and plug them in and connect the dots, because it's just a line. So if you connect the dots, you'll have the equation, the graph. So 0 plus 1 is 1. That fills in my open circle. Then negative 2 plus 1 is negative 1. So it's right there. And then solid on both, connect the dots. That's the middle piece. Same thing for the last one. 2 minus 1 is 1. Open circle, slope of 1. So it's kind of just shooting off that way. So that'd be the graph. Domain is all reals. Every x value shows up somewhere. Range would actually also be all reals. Almost looks like there might be a gap in the y's right there, but this is a y value of 1, and it fills in that one. So then you get all the positives above 1 there, and all these numbers below 1 there. F of 1 is going to be 0. If I just look at the picture, I can just see that right there, right? This next question down, is this relation 1-to-1? It is not 1-to-1. I would say it is 1-to-2. Nope, not 1-to-2. I messed that up. I'm sorry. It is 2-to-1. Because you could take like any part in this V that's right here, like this and this, they have two different x values that give you the same y value. So it's 2 to 1. Is this relation a function? Yes. It passes the vertical line test. Okay. So this last question is kind of tricky. It's saying if f of x minus 4 is 12, find x. So the output is 12 is basically what gives it away to me. The only way I get 12 is if I'm up here on the red part, because it's the only place I get positive numbers, and the shift is just to the right 4. So you can imagine, I guess, that you also need to think of those together. But if you move this over to the right 4, the only way you're going to get 12 is with that piece. So then I look at this piece, which is x minus 1, and basically I'm just going to set up an equation and solve it. So I'm going to do, the input is x minus 4. It's going to go in right there. So we're going to get x minus 4 minus 1, and we set that equal to 12. And then we just solve for x. So we get x minus 4 equals 13. And then if you add 4, you get 17. And that's it.